since it's 10 o'clock, we'll go ahead and get started. What we're going to be covering today is section 7.4, which is solving what's called quadratic equations. And we're going to do two different methods. We're going to solve them by, the first method will be by factoring, and then the second method will be by what's called the quadratic formula. So what exactly what makes an equation be quadratic instead of just a regular equation? Most equations that we've solved so far have just been what are called linear equations, which means they just have an x. So something like that, where you would solve for x, get the x by itself, which means in this situation you would get rid of the plus 7 with a minus 7 to get 2x equals 5, and then divide by 2. So x would equal, that fraction doesn't reduce, so that x would just equal 5 halves. That is what's called a linear equation, when the only thing you have to solve for is just an x. What makes an equation quadratic is if you have an x squared that you're solving for. You're still solving for x, but you're going to get two answers instead of just one in a quadratic equation. Okay, so one of the ways that we're going to do first, which is by factoring, is you can solve this by factoring what's called this trinomial, which is this 3 terms. And when you're factoring, it's kind of like you're unfoiling. You're taking this back down to what was foiled to get to here. So if I'm going to factor this and put it back down into the factors, or what was multiplied together to get the x squared plus 8x plus 7, these two terms that would be at the beginning of each factor would have to multiply to equal x squared. Well, the good news is there's only one way to do that. X times x is the only way to multiply to get x squared. Then you need to find out what's going to go at the end of each of those factors. The numbers that go at the end of each of those factors have to meet two requirements. First of all, they have to multiply to equal 7. They have to multiply to equal whatever that last term is. So if I'm going to multiply, let's see, how do you multiply to equal 7? 7 times 1. There's only one way to do it, which means that's good news. Not only do these terms here have to multiply to equal 7, they have to add to equal what is in the middle here, which means I have to add to equal 8. So I would choose, if there was more than one pair over here, I would go through and find the one that added to 8. And luckily, our 7 and 1 does add to 8, right? And they're both positive, right? Multiplying to equal positive 7 and adding to equal positive 8 will be a positive 7 and a positive 1. After you do your factoring, you look at your two factors and you set each of them equal to 0. So I would have x plus 7 equals 0. And x plus 1 equals 0, and then solve both of those to get your two separate answers. So if I solve this for x, I would have to subtract the 7 from both sides to get x equals negative 7. And solving this one, I would subtract the 1 from both sides to get x equals negative 1. So those would be your two answers. If you plugged in negative 7 or negative 1 in for these x's, this whole side would turn into 0 to equal the other side. There's two solutions that make that true instead of just one like a normal linear equation. So we're going to work through some of the problems in 7.4. So that method is the factoring method, which is what you can use for number 1. So that problem that I just did is very similar to number 1. It says find the zeros of the following function. Finding the zeros means finding the solutions. It also means finding what would be the x-intercepts of this equation. Okay, and we'll get more into that when we do 4.8. So the finding the zeros means find the solutions. F of W equals W squared plus 12W plus 27. So if I'm going to find the zeros or find these solutions, what that means is find where this trinomial equals 0. That's why it's called finding the zeros. So 0 equal, when does this equal 0? So if it doesn't already have a 0 here, then you need to rename that F of W to 0. It wants to find when that equation equals 0. So let's check out our factoring method. Does this trinomial factor? Let's see, let's try it like we did the last one. Good news is it's just W squared, so W and W would equal W squared. Now remember how to fill in these back numbers. They have to multiply to equal the last term. So I'm multiplying to equal 27. There's 2 ways to do that. 27 times 1 and 9 times 3 also equals 27, right? So there's 2 different ways to do it this time. So I need to choose the pair that does what? That also adds to 12. So out of this pairs, who adds to 12? The 9 and the 3 do. So I would use plus 9 and plus 3, right? If they're going to multiply to equal positive 27, does that check? 9 times 3 does equal 27. Do those numbers also add to positive 12? 9 plus 3 is 12. So they would need to do those 2 things. And then set these equal to 0. So W plus 9 equals 0. And W plus 3 equals 0. And then solve those to get your 2 solutions. So subtract the 9 from both sides here. W equals negative 9. And here subtract the 3 to get that W by itself. So W equals negative 3. Okay, so if you want to match up what I am doing today on the board with how your homework is going to go, I'm doing them out of order. This will match your number 1. I'm going to skip number 2 and go to number 3. We're actually going to do number 2, or the problem like what's going to be your number 2 last. Okay, because it has something that we need to get used to just using the quad formula before we jump into number 2. So let's look at number 3. It also says find the zeros of the function. X squared plus 5x minus 3. It already says equals 0. X squared plus 5x minus 3 equals 0. Now, don't even write this down. What happens if you try to use the method that we used on the other problems that we've solved so far? Again, don't write this. You would start off with x and x for x squared. But then remember, you'd have to find numbers that multiply to equal -3. There's two ways to do that, just by flipping your signs, right? Because if you're multiplying to equal -3, you're going to need a positive and a negative. So I can either do it with +3 times -1, or flip those signs around. -3 times +1. Both of those situations, check the first box. They have to multiply to equal -3. But then, what is the second box you would have to check in order for this factoring to work? You'd have to pick the pair that adds to +5. Neither one of those will do that, right? 3 plus -1 is 2. -3 plus 1 is -2. So neither one of those ways will add to what I need it to, which is +5. So that's why we have the quadratic formula. Which is that. I'm going to shut the door. They shut it in my last time. So here's the quadratic formula. X equals, I'm going to call this the opposite of b instead of negative b. I'm just going to say the opposite of b plus or minus. Then I have this long square root, and underneath that square root, I've got b squared minus 4 times a times c, and that's all over my denominator of 2 times a. So here's the problem I'm trying to solve. It is going to come up with 2 solutions. The reason it comes up with 2 solutions using this formula is because of that plus and minus. So let's look. I need to figure out what my A, B, and C are. The A's, B's, and C's are what you're going to plug into that formula. Your A is always the number that's in front of your x squared. There is a number in front of this x squared. I just don't see it, which means it's a 1, right? X squared just means 1x squared. Your B is always the number in front of your x. So in front of my x, I have a 5. C is always your constant, which just means the number that doesn't have a letter hooked onto it. That's your constant. So my constant is -3, right? It's got a minus in front of it, so -3. Now that you have picked out your A, B, and C, you're going to replace the A's, B's, and C's in this formula with what number that represents them. So let's see. What's the first thing I need? I need the opposite of B. So be careful here. Here's my B, which is 5, which means the opposite of it's going to be -5. So after the opposite of B, then I'm going to have that plus minus. Now I'm going to have this long square root with all this underneath it. The first thing underneath my square root is a B, but square it, which means multiply it times itself. So what is my B squared in this situation? 5 squared, which would be 25. Now, after the B squared, this -4 is always there. It's part of the formula. Then you're going to plug in A and C, the number for A and the number for C. So let's see. My A is 1. My C is -3. And then I'm going to put that all over my denominator, which is 2 times your A, which in this case is 1. Now, after you replace, you're simplifying that fraction. You can do a lot of it, or this part right here. That's your first step of simplifying, is figuring out what all that is underneath the square root. You can do it all at once in your calculator. Type in exactly what you see. 25 minus 4. Then, just like it says right here, open parentheses, 1, close, open parentheses, -3, close. It'll do all that math at once. It follows the order of operations and everything. And so again, you just want it to look exactly like what is underneath your square root. 25 minus 4 times A times C. And then hit enter, which gives you 37. So everything under here turned into 37. So now I have -5 plus or minus the square root of 37. And then your denominator, just do that multiplication. 2 times 1 is 2. Now, your problem is going to ask for two things. It's going to ask for exact solutions, and then it's going to ask for the approximate solutions rounded to 3 decimal places. This is your exact solutions. It actually is 2 answers. The reason it's already 2 answers is because the plus and minus. It just pushed those 2 answers and showed them together. The 2 answers, if you wanted to, you don't have to, and I'm going to show you at the end how to type that into MathLab to where you don't have to separate them and type it all in twice. You just type in -5. There is a plus minus button that you can click on. Down in that toolbox at the bottom when you're typing in your answers, there's a little thing that says that has plus minus together. So if you type them in separately, the 2 separate answers would be -5 plus the square root of 37 over 2, comma, -5 minus the square root of 37 over 2. That would be your 2 separate exact answers. Now, how do I get the approximate solutions? You would have to type in your calculator -5 plus, now the way I type in the square root of 37 is you hit your second button and then go down to the x squared button, and you'll notice the blue that's right above the x squared is a square root. So if you hit that, that'll give you that square root that you need. And then type in the square root of 37. Hit enter, but then what do you need to divide that by? What is your denominator? Divided by 2. So just go ahead after you type in the numerator, -5 plus the square root of 37, get your answer, and then divide your answer by 2 and hit enter. So there's your decimal, 0.54138. Blah, 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 all the way down. You want to round that to 3 decimal places. So what you actually want to look at is 4 places behind the decimal, right? So let's write that out, 0.5413. The reason I say that is because it wants you to round it to the first 3 decimal places. So that's why I drew this line right here. It doesn't want to see any of the numbers behind that. But I do need to see this number to decide whether I need to round that 1 up to a 2 or not, right? What makes this 1 round up if it was going to? If that is 5 or higher after my little line right there. So since it's not, that means that 1 does not round up, so it's just 0.541. So there's the first approximate solution, right? It's not exact like this because there is way more decimals that goes on after that. I'm just rounding it. So that's why it's approximate and not exact. So now I need to do the other approximate solution, which would be -5 minus second square root 37, enter, and then divide that by 2, because that's your divided by. So this one I have -5.541. So there's 3 spots. So again, I need to go one more. And again, I'm going that one more to see whether or not that 1 rounds up or not. And it only rounds up if that's a 5 or higher. So since it's not, that 1 doesn't round up. So those are your 2 approximate solutions. I'm going to skip forward and come back to it also. So that was like number 3. That should match up pretty well with your number 3. Let's go to number 5. Because remember, you can work your homework out of order. You don't have to work it in order. You can skip and come back. Number 5, find the zeros of 3x squared minus 7x minus 5. So it's already set equal to 0 for us. So I'm going to go ahead and choose my A, B, and C. My A is in front of x squared, so it'll be a 3. My B is in front of x, so it is -7. And C is my constant, which is -5. So let's plug these into my formula. What do you need first? The opposite of B. So the opposite of B, since your B is -7, the opposite of it is going to be +7. Then the plus minus from the formula, that's what gives you your 2 solutions. Then you have the long square root. Under your square root, you need your b squared. If you square -7, what does that mean? That means -7 times -7, right? So if you are squaring stuff in your calculator and it's negative, you better put parentheses around it, because if not, it's going to give you the wrong answer. So -7 squared is 49. Now, that number right there, it's always going to be positive, right? Because it doesn't matter if your b is negative or positive. If you square it, it's going to end up positive. So if you have a negative number right here, that's going to be wrong. So 49, then what comes next? That -4 that's always there because it's part of the formula. Then your A and C, which in this case are going to be 3 and -5. Then your denominator is 2 times your A, which in this case is 2 times 3. Now remember, the second step is whatever is underneath your radical, type that exactly into your calculator. So let's see, I'm going to have 49 minus 4, open parentheses 3, close, open -5, close. So again, what is in your calculator needs to exactly match what is underneath that radical symbol. And hit enter. So all of this, when I type that into my calculator, gives me 109. So 7 plus or minus the square root, all that turned to 109 over 2 times 3, which gives me 6. So again, there is your exact solution, plural. To get the approximate, you do 7 plus the square root of 109. So 7 plus second square root 109. And then divide that by 2. Oh, divide it by 2. Don't divide it by 2. What do you divide it by? That's 6. 7 plus square root 109. Enter and then divide it by 6 to get 2.9067. Again, I went 3 spaces because that's what it's going to want me to round it to. And then I went 1 more, right, to get that number that tells me whether I'm rounding up or not. So in this case, the number after is a 7, which means this 6 does round up to 7 since the number after it was 5 or greater. So I would have 2.907. Your other approximate solution would be 7 minus the square root of 109 divided by 6, which is negative 0.5733. Again, I went 4 spots so I can decide whether I need to round up or not. Since the number after the line is not 5 or higher, that means that 3 will not round up. So there's your 2 approximate solutions. Number 6. And then we'll go back and do 4, and then we'll go back and do 2. All right, number 6, just ask for the zeros. It just asks for the exact solutions. F of x equals 3x squared minus 5x minus 11. So again, I want to find out when this equals 0. I'm finding the zeros. So turn that side into 0 equals 3x squared minus 5x minus 11. Choose your A, B, and C. My A is in front of x squared, so that's 3. My B is in front of x, which is negative 5, and C is my constant, which is negative 11. And plug them in. So the first thing I need is the opposite of my B, and you'd be surprised how many people get that part wrong. Right? If your B is negative 5, the opposite of it's going to be positive 5. Then plus or minus the square root. Then your B, but square it. So negative 5 squared is positive 25. Then minus 4 from the formula. And then your A and C. A and C are 3, negative 11. All over your denominator again is 2 times A, which is 2 times 3. So let's see, what is underneath the square root simplified to? So 25 minus 4 times 3 times negative 11. So once again, you're just making what's in your calculator exactly match what's underneath that radical. So I hit enter and it gives me 157. So 5 plus or minus the square root of 157 over 2 times 3, which gives me 6. So there are your zeros. This one doesn't ask for the approximate. It doesn't ask for the decimal answers. All right, going backwards to number 4. Find the zeros. F of x equals 5x squared minus x plus 9. So finding the zeros means turn that side to 0 to see what makes this equal 0. So 0 equals 5x squared minus x plus 9. Choosing A, B, and C. A is 5. B is the number in front of this x. So since it just says minus x, that means minus 1x, right? Which means your B is negative 1. And your C is positive 9. So something a little different happens on this one. Plugging in the opposite of B would be positive 1. Then plus or minus your long square root. Under the square root, I need B squared. So negative 1 squared is positive 1, right? If you square negative 1, that means to multiply negative 1 times negative 1, which is positive 1. Then minus 4 times A and C. This time, what are A and C? 5 and 9. All over 2 times A, which is 2 times 5. So let's see, what's going to make this one different? Let's type in what is underneath our square root. You're going to have 1 minus 4, open parentheses, 5 close, open a 9 close. So again, make what's in your calculator match exactly what's underneath your square root and hit enter. Negative 179. That's what's a little bit different. What's underneath here ends up negative. My denominator, 2 times 5 gives me 10. Now, if you took transitional, maybe this is fresh on your mind, but you can't leave a negative underneath a square root. This is what's called an imaginary number. It's actually not a number on the number line. Okay, the way that you can write this without writing the negative underneath is you're taking out the square root of negative 1. The square root of negative 1 is equal to I. So it's like you're factoring out the negative. You're pulling out the negative, or in other words, you're pulling out the I from that square root. So the way I write this with a positive square root is 1 plus or minus, put your I right here, which makes what's underneath your square root turn to positive 179 over 10. So once you get to the end, if your square root, what's underneath it is negative, pull out the I to make it positive. So that's probably going to happen on your number 4. It will happen on your number 4. number 2. All the ones that we've worked so far, I haven't brought up that there could be a step after this. And what makes that happen is if what's underneath your square root can simplify. Let me just refresh your memory in case you didn't take transitional last semester or this past summer, or it's been a while since you've done this. Let me just refresh your memory. Let's do a couple of just simplifying a radical, if it does. Let's do these two. What I mean by your radical will simplify is if it has a factor that is what's called a perfect square. Your perfect square numbers are 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So these numbers that I'm listing here are all what are called perfect square numbers. That is because any one of these numbers, if I take the square root of it, I get a whole number instead of a decimal, right? The square root of 36 is 6. The square root of 9 is 3. The square root of 25 is 5. You see what I'm saying? These numbers are perfect squares because when you take the square root of them, you get a whole number instead of a decimal, right? If you try to take the square root of 7, you're going to get a big long decimal, right? Because 7's not a perfect square like 1, 4, 9, 16, and so on are. So if you have a radical or a square root that has a factor, a number that goes into it that is a perfect square, you've got to take care of that. 50 can break up. Now here's the thing, when you break them apart, the two numbers have to multiply to 50. If not, you've changed it. You've changed the number. And this first one has to be the factor that's a perfect square. So let's see, how do you multiply to get 50? Those ways, right? 50 times 1, 25 times 2, and 10 times 5. 1 doesn't help me. We don't ever use 1 just because it doesn't help me in this process. But when I'm looking at these other numbers, which one of these numbers can you take the square root of or is a perfect square? Which one of these numbers, in other words, is in this list? That one right there, right? I can take the square root of 25. So that's what I'm going to use to break this apart. I'm breaking apart the 50 to 25 times. This part over here is just kind of like your leftover, your trash, after you pull out the perfect square. Because remember, these two have to multiply to 50. So that's why the 2 comes here, because 25 times 2 gives you the 50. So what you did is you put a perfect square in that front radical. Now you're supposed to, since you put it there, now you got to take the square root of it. So what is the square root of 25? It's 5. Drop down the square root of 2. So the square root of 50 will simplify to 5 square roots of 2. So let's try the 27. Will it break apart to 2 numbers where one of them is a perfect square? How do you multiply to get 27? 27 times 1 and 9 times 3. Remember, you don't ever use the number times 1. Even though 1 is a perfect square, it doesn't help me. It doesn't help me because I still have a 27, which means I still have the same exact thing. But look at that other pair. Which one of these numbers can you take the square root of? 9. 9 is a perfect square. So I'll put the 9 in my perfect square radical. 9 times 3 is 27. And then the square root of 9 is 3. Bring down the square root of 3. So the square root of 27 simplifies to 3 square roots of 3. On all of the other problems that we've worked so far, the numbers that we've gotten underneath our square roots just haven't simplified. We've gotten 37, 109, 157. Those are just numbers that won't do this. They don't have a perfect square factor. But number 2, let's work number 2. F of x equals x squared minus 2x minus 4. So if I'm finding zeros, I need to see what makes that equal to 0. Equals x squared minus 2x minus 4. So it doesn't factor, so let's go ahead and pick our A, B, and C. A is in front of x squared, which will just be a 1. B is in front of x, which is negative 2. And C is your constant, which is negative 4. Plugging in. Opposite of B, so the opposite of this is going to be positive 2. Then your plus or minus. Then your B squared, this number squared, negative 2 squared is 4. Then minus 4 times A and C, which is 1, and negative 4. All over, your denominator is 2 times A, which is 2 times 1. When I type this in my calculator to see what's underneath my square root, it gives me 20. So this all turns into 20. So I'm going to have 2 plus or minus the square root of 20 over 2. Now, here's why this one goes further. Unlike the other ones, 20 can simplify. It does have a perfect square factor. Because how do you multiply to get 20? Let's see, 20 and 1, which we won't use, that won't help us. 10 times 2, I still don't have a perfect square, right? Neither one of those numbers are perfect squares, but look at this next way. 5 times 4. There's my perfect square, right? I can take the square root of 4. So this will break apart, just like I was doing when we were practicing this. So I'm going to have 2 plus or minus. I'm breaking apart that 20 to its perfect square, which is 4, times 5 is 20. So all I've done on this step is broke apart the 20 to 4 times 5. It's still over 2. So just like when we were practicing, now that you've made a perfect square right there, now you got to take the square root of it. What is the square root of 4? It's 2. So this is going to turn into a 2 now. So now I have 2 plus or minus 2 square roots of 5 over 2. Last thing. Sometimes your fraction at the end will reduce. It reduces if this number, and this number all have the same number that goes into them, just like you would reduce any fraction. What goes into all those 2's? 2 does, right? 2 goes into 2. So if I divide these all by 2, that'll turn to 1, that'll turn to 1, and that'll turn to 1. So let's write what this actually, after I've simplified it, looks like. What's in front of that plus minus now? A 1. Plus minus. What's after the plus minus? I actually have 1 square root of 5. 1 square root of 5 is just the same thing as saying the square root of 5. If you write the 1, it's not going to mark it wrong, though. So 1 square root of 5 is just the square root of 5. Now, what's your denominator? Now that you've simplified those 2's into 1's, your denominator is just 1, which means you don't have to write it. Right? If you have a fraction, but it's over 1, that 1 is unnecessary. So those are your 2 solutions. 1 plus and minus the square root of 5. Now, after all of this, if you have the quad program in your calculator, you can work every single one of these problems in your quad program. If you have it, it will be in this program button that says PRGM. If you hit that, you may have a list of programs listed there. If not, it'll just be blank. If you don't have it, I can give it to you, but I have to physically see you because I have to connect our calculators together. Okay, which I will do for everybody in here in just a minute. But watch this. If I go down, the quad program is just called QUAD, is what it's usually called. So here's mine. There's my quad. Ask me if I want to do program quad. My answer is yes. So I hit enter. Look what it asks me. It asks me what my A is. What is my A on this last problem? It's 1. So that's what I'll tell it. A is 1. Enter. Then it asks me what my B is. Well, my B is -2. So that's what I'm going to tell it. -2. Enter. Then it asks me what my C is, which this one is -4, so that's what I'm going to tell it. Now, when I hit enter, the very first thing it's going to give me is the decimal solution, which are your approximate solutions. Now, here's what's crazy about MathLab. Or it's not crazy. The MathLab, the first thing it's going to ask you for is the exact solutions, which is the 1 plus and minus the square root of 5. And then it's going to ask you for the approximate solutions. So when it asks you for the approximate solutions, these are the numbers that it wants you to round to the 3 decimal places. So that's what you'll use. Now, look what happens when I hit enter again. 1 plus the square root of 5 and 1 minus the square root of 5, which is what my 2 answers are. 1 plus and minus the square root of 5. If I would have worked number 4, that one I worked right before this that gave me the I, let's see, I'm going to clear that out. Go to program, down to quad again. So there's my quad, hit enter. My A, B, and C on this one, going backwards to number 4 that we worked just a minute ago, were 5, -1, and 9. 5, B is -1, and C was 9. 1 plus, there's your I, square root of 179 over 10. 1 minus the square root of 179 over 10. I'm not ever going to tell you that you cannot use this. If you are taking higher math and you have to solve quad formula, I would never imagine that they are not going to let you use the quad program, because they want you to get to this answer real fast so that you can use it to answer what they're asking you. This would just be like part of a problem. Find the zeros, and then what does that mean? What are you going to use those for? They want you to get that part fast. They don't want you doing all this. They're just assuming you already know how to do all that. Okay? So if you don't have quad program and you want it, you need to email me. They do have the cord in the tutoring lab that's in the campus center building on the 3rd floor. It's almost right across the hall from 311, which is our classroom. It's down towards the stairs a little bit. I can't remember the exact number, probably 310, something like that. But they have the cord in there. So if you want to connect and get the quad program, they should be able to do it for you in there. Or if you come to class on Wednesday or Friday, I can connect our calculators together and give them to you. If you are virtual and you just want to come up here for a minute, come either right before or right after class, and I can still connect our calculators together. You're going to want the squad program on your calculator. Okay? All right. I will see y'all Wednesday.